It is selected and added to the topology table. As long as this line is cut off in the future, this line can start forwarding immediately. This is where EIGRP is very powerful. OSPF is impossible. How to meet the conditions? This has to wait till the end, because its overall design is at the end. We just saw. There are two next hops in the topology table. Refers to this. The one above will be the main line. Into the routing table. Because in the routing table you can see it too. That for now. It also appears in the topology table. We can implement its addition table later. Let's talk about this later. Here's some of the algorithms we're talking about. Fast convergence is when the overall topology changes. A fast convergence can be achieved. This word is not easy to understand. Convergence is the synchronization of information as a whole. And optimize the current forwarding path. Realize normal forwarding. The forwarding speed of EIGRP is very fast, since it has the contents of the current topology table. So it can achieve a very fast convergence mechanism. But I tell you, if now there are two lines, this line is the main line. In routing table, this route is a suboptimal route. But it doesn't satisfy the condition. If it is not in the backup topology table, then it has no way to forward it immediately. It also requires a protocol mechanism. Do the calculation yourself. That is, it can be added to the list is conditional. But if entered into the table, it's switching in seconds. Let's look down. This algorithm actually draws a picture. I'm in this experiment. Restore this picture. Let's just wait and do it. Okay. Next we look at some terms. I ask everyone to listen carefully. These things you have to remember. First look at the successor router. A cost is identified here. This is for the convenience of everyone to understand. Actually, strictly speaking, a metric should be marked here. Because it is not called cost in EIGRP. Called metric. But the meaning is the same. The cost value above is a total of 40. 10 plus 30 equals 40. The following cost value is 20 plus 30. A total of 50. That is to say, it must be the above route, because its overall routing metric is smaller. This protocol mechanism is consistent with what we said before. Both lines learned via EIGRP. The overall measure of the above line is smaller. Just take the above route. That is to say, now if going to 4.4.4.4, logically, it should go like this. This is called the main line. This is the line going in and out now. The lines that appear in the routing table will definitely be added to the table, because it is the best path. Then for this optimal path, it has a thing. Successor router. Successor router means, if the current main line is the above line, then take R1 as an example. R1 goes to 4.4.4.4 and takes the above route. For this optimal route, the next hop router of this optimal main line. Successor router. R1 if going to 4.4.4.4. Give traffic to R2. It is the successor router to the route entry 4.4.4.4 on R1. Because only the optimal route is added to the table. It is the successor router of this route. Certainly. This is all for R1. It's different if you change the device. Looking further down is the feasible distance. From R1 to destination network 4.4.4.4. The optimal total metric for this route. That is 30 plus 10 equal to 40. Further down is the advertised distance. Advertisement distance has two words. One is RD. One is AD. But we basically call it AD. It's just a title. Don't need to bother with it. Still for the device R1. The advertised distance refers to the R1 going to 4.4.4.4 in the future. Its successor router. That is R2. Feasible distance to destination network. The advertising router refers to the R1 now reaches the route 4.4.4.4. Feasible distance for its successor router to reach 4.4.4.4. That is 30. That sounds a little boring. And not easy to understand. I try to keep it as simple as possible. For example, there are 3 locations. Suppose this is A, this is B, this is C. It means A to B is 10 meters. B to C is 20 meters. Then A to C is called its feasible distance. B is the successor router of A. Feasible distance from B to C is called the advertised distance of A. Okay. Further down is the feasible successor router. Let's not talk about this. Let's talk about the feasible conditions first. Because only after the feasible conditions are met, there is a successor router. So let's start with the feasible conditions. The feasible condition is, if now there is a path, it can satisfy a parameter. We call it an alternate path. The AD of the alternate path is now less than the FD of the main path. Then it can be a qualified alternate path. Let's take this picture as an example. Now the following line. Its alternate path is the following line. Because the above is the main path, AD is the advertised distance. If its next hop router is R3, this is called its advertised distance, is 30. So now the FD of the main line is 40. 30 is less than 40 now. Suppose you use it as a backup line. Then you compare. Now indeed its FD is smaller than the main line. Then this path can be an alternate path. So what we're talking about? It is a feasible condition, called FC. If this feasible condition is met now, then the following path can be a backup path. Then it can go into the topology table. Then the next hop router on this backup path. Feasible successor router. Real mainline router. Successor router. The next hop router on the backup line. Feasible successor. Then the condition for generating a feasible successor router is, the line must now be available. That is, if the current route satisfies the feasible condition, it becomes a backup line. Then this router will become FS. Feasible successor. Here are some features between them. That is to say, for a line, we have to compare such values. If this value is not met, it cannot enter the topology table. I want to ask you a question now. If it's not 30 now, I changed it to 40. So now in this path, is there still a viable post router? I saw someone ask how to choose a backup link when there are 3 lines. The same. If the 3 lines, you calculate again. As long as it is now eligible, it also enters the table. That's just in the topology table. Middle line. It will also be compared with the following lines. If both of them are exactly equivalent, then they are loads. If they are not exactly equivalent, because we'll look at 2 parameters later, they are hardly completely equivalent. As long as feasible, it becomes the backup line.